Okay, so my talk is going to be about movement in the kidney, so I'll let you get used to my accent, which is different. But this is all going to be about kidney, which may or may not be familiar with everybody here. So I have no conflicts of interest to declare for this project. So kidney motion is an interesting organ because it's quite close to many of the other organs that we treat, like the liver and the pancreas and this upper abdominal area. But mostly we treat it as an organ at risk, not as something that we want to treat. In fact, our previous speakers spoke about MRI LINAC, and I think that is a really good solution to be able to visualize the kidney. And it's probably the perfect solution to be able to see something in real time and be able to treat it at the same time. Although we also discussed that the treatment times are quite long when we're treating gating during MRI LINAC treatments, but still it's a really optimal solution for this upper abdominal area. Now, I don't have an MRI LINAC, and what we're used to most commonly is just 4D CT. And this is just an example of what we would expect to... can I go back? Yeah. Just to what to expect with a 4D CT. Anyway, there's some motion there from what we should expect. Never mind. Okay. But 4D CT is probably something that we would typically see in our normal practice when treating on a conventional linear accelerator. How do I progress? Help. There we go. Okay. So this is the example of, on that left-hand side, we can see a kidney there. Now, before we started our program, we actually did something important in our institution. We looked at patients who had normal kidneys and had them undergo a 4-dimensional CT scan. And in this study, we looked at 71 consecutive patients who had a 4D CT with no tumor in the kidney, so just a normal kidney. And we found that the average tumor motion is about 3/4 of a centimeter. So 75% of the time, we see most of the patients having tumor motions less than 1 centimeter in size. The average tumor motion, 3/4 of a centimeter. Most patients have, 75% of patients have tumor motion less than a centimeter. So in fact, these patients probably don't need anything too fancy for treatment gating or for motion management. There are some extreme outliers, though. In the 71 patients, we did see that there were patients who had movements of 2 to 3 centimeters in size. And this smaller group, it was about 10 to 20% of the patients. These are the ones that we need to keep a very close eye on and use some more advanced motion management techniques. We also looked at the literature, looking at all of the different studies that looked at free breathing kidney motion, and everything is very consistent. So for the 15 studies that we looked at free breathing kidney motion, the average motion was less than 10 millimeters in size. So most patients probably don't need anything too advanced. So our technique at Peter Mac when we started our program has been very consistent for a period of about 10 years' time. We used a system which has dual vacuum immobilization. So a vacuum beanbag at the bottom of the patient and a vacuum on top of the patient to help reduce tumor motion and to allow immobilization. It finished in 2022, and I'll explain to you why. But the system is a bit like this. Basically, we take the patient to the linear accelerator. We have already the vacuum bag underneath the patient, but we just apply this shrink wrap, cling wrap on top of the patient and use a vacuum to be able to reduce that air out on the top of the patient. And this allows for a very good immobilization for what is a relatively long treatment time. Now, what we do now is we don't use that top drape anymore, and there's a reason for that. But part of the reason why it's important to keep a patient immobilized is that because the treatment times a decade ago were quite long. This is an example on a linear accelerator from Varian, and we had imaging with cone beam CT whilst the patient was immobilized in this vacuum. And the image quality is okay. It's not an MRI LINAC. It's not perfect. Abdominal gas is an issue, but we don't capture motion in real time. We're looking at an average motion blur within the tumor and an ITV concept for treating the tumor. And the kidney we also use as a bit of a surrogate for the tumor location and tumor motion. So we can see relatively good images, but we don't see very good quality of where the tumor is in relation to the kidney. It's mostly that whole area, the kidney and the tumor together, that we're looking at. Now, one thing that we did do is, because we recognize the limitations of a linear accelerator and cone beam CT, we also took an image at the liver diaphragm, the dome of the liver, because there is something that you can do, which is measure the gradient between the top of the liver dome and the bottom of the liver dome, which represents the breathing motion. And this is something that you can use with a simple profile tool on a Varian Linac, just measuring that area from low density lung, middle density motion, and bottom density, which is all liver. This was useful because we can get a measurement of what the patient's breathing is. So at the mock-up, the green line there is what we see for the patient at the time of preparation for treatment. It's a 1.6 centimeter motion in the kidney based on measuring the kidney liver dome. And when this patient represented, they actually took a deep breath, which was not expected. This patient was speaking Mandarin. We had to translate for them, and they took a deep breath by accident. In addition, they thought they were meant to take a big breath, but they weren't meant to. And this is the way that we picked it up. We were able to tell that even though the kidney didn't match up in the imaging, the reason was because the patient was breathing differently. Very simple techniques, very basic. The way we used to treat as well was very basic as well. It was using non-coplanar techniques. Now, all this morning, we haven't been talking about non-coplanar because everybody's moved to VMAT. It's very simple. We still use non-coplanar on occasion when we think it's the most optimal way to get a dose distribution. It's very rare. We don't use it that often. It's probably only in about maybe 1 to 5% of patients, but it is still an option. And this is the example of a stereo map of all the different areas that we were treating, basically showing the different distributions of beam angles. They tend to be most posteriorly located and laterally located, but a whole bunch of non-coplanar beam angles too. So what did this mean for treatment time? 10 years ago, this is what we did for imaging time. The cone beam CT time for a 3-fraction approach was about 8 minutes, and the patient treatment time was 31 minutes up to an hour. So 44 minutes on average in total. For the fractions, for a single fraction, it's about 50 minutes in total. But these are long treatments a decade ago. That immobilization really helped. So what I want to try to impress to you is we can be very fancy with all our techniques, but maybe we don't need to be for getting good results. This is our initial trial, Fast Track, and it's the same process that we use even for the last almost 13, 14 years now. Which is a single fraction of 26 gray, 3 fractions of 14 gray for larger tumors. Very simple, ITV based for the majority of patients, so motion encompassing. The minority of patients get gating or motion management, and we ask for a good coverage of the tumor and a hotspot. So those results for our initial cohort, the very first pilot study, we had 33 patients and 34 kidneys, and it was a large tumor size at almost 5 centimeters in size 1 decade ago. And of these patients, we had a median follow-up of 2 years that we published. Only one patient had a grade 3 treatment-related toxicity, which was fatigue. The patient had 2 big kidney tumors. We treated both at the same time. He stopped riding his bike every week and stayed on the couch for a few weeks. But there were many patients who had no treatment side effects, even though having large tumors, and the control rates were excellent. So what did we change in the last 13, 14 years since this time? So what we have done is we've introduced contrast CT for imaging and delineation of tumor. Now, this is a complication because we can't have the contrast CT and a vacuum drape on top. So we've stopped doing the vacuum drape to allow us to see this tumors a little bit easier. This is very important because with the contrast 4D CT, visualizing the tumor is much, much easier than it is on a non-contrast CT. That's the protocol that we use. It's pretty straightforward. You can always email me and my team can send you a protocol. This is our techniques over the last 3 years. So 2024, 22, 23. So we are gradually dropping the number of patients getting an ITV approach. It's gone from 3/4 of patients maybe to 67%, pretty similar. There are more patients who are having more advanced techniques like exhale breath hold, DIBH and gating, but it's still a minority. So yes, most patients can be treated in a very simple approach, but there is a minority of patients we need to think about these more specific techniques. Now, this is the actual workflow, if you're interested, but basically, if a patient we think when we have fluoroscopy at the time of 4D CT, we can see a large tumor motion, what we do is we assess them for 15 seconds on an exhale breath hold. If they can do the breath hold, that's our preferred technique. We go down this pathway, we check that the liver dome is consistent on repeat breath holds, and that's our preferred pathway. If they can't do the breath hold, then we look at the consistency of breathing and whether we can gate. Or last step, we try to do some kind of compression. We don't like doing that actually because I think that brings all the organs at risk closer to the target, which is not great, but it is something that we can do if everything else doesn't work. This is my last slide, and I just want to impress that we can do things very simply. We don't have a very simple building. This is our beautiful building in Melbourne, and I hope that someday you can come down and maybe have a beer with me, and I'll show you around the building. Thank you.